Hello everyone. So we are moving on to paper 4 and it's under the connected body topic. Yeah. So what we are seeing here, I've already drawn some of the forces here, tension, weight, and also acceleration, where the system is going. I've also underlined some of the important info such as the angle where sine theta is equals to 3 over 5 and also whether what's whether the plane is going to be smooth or rough, and it looks like it's smooth, so definitely friction does not play a role here. Okay, so now let's move on to part 1. You want to find the tension in the string and the magnitude of acceleration. So first thing that we're going to do is we're going to use the F is equals to ma, but let's focus on one particle here. Let's move with Q. Okay, so Q for F is equals to ma. Weight is bigger, tension is smaller, is equals to ma. So its weight is 2 minus the tension, which we're trying to find later, and then 0.2 acceleration. Okay, so that's equation number 1. Moving on to P. Tension is bigger, right? But weight is smaller, but since it is not in vertical motion, we have to convert the weight in parallel to the slope. Okay, so it's going to be W sine theta, and theta is going to be inverse sine 3 over 5, yeah, equals to ma. Okay, so now what I'm going to do is the weight of the P is 3 and sine inverse sine cancel each other out, so we'll have 3 over 5 is equals to 0.3a. Then let's simplify this. We get 9 over 5 equals to 0.38, and we have our second equation. Now let's move forward to doing simultaneous equation. Yeah, so part 2. So step 2, I'm going to make t as a subject, and I have 0.3a plus 9 over 5. Now I'm going to substitute this into the first equation, where we have 2 minus bracket 0.3a plus 9 over 5 equals to 0.2a. Let's expand this. Okay, now let's bring all of the a's to one side and the one without on the other side. Okay, now let's simplify this. We get negative 0.5. And we get negative 1 over 5. Okay, so now let's bring the a to the side. And we get 0.4 meter per squared second. Okay, acceleration done. Let's find out the tension. Tension is going to be 0.3, 0.4 plus 9 over 5. Tension is equals to 1.92 Newton. Now, okay, so those are your accelerations and tensions. Now let's move on to the next question. Now for the next question, we want to find the time from when the instant when P is released for which Q to reach the floor. So it's from when it was released until it reaches the floor. So we've already found the acceleration. So I think the best that we can do here is we have distance, we have initial velocity, we don't have final velocity. We want to find time. We have acceleration. So the most reasonable thing to do, let me double check. We cannot assume it ends in 0, so we'll have to use the s is equals to ut plus half at squared. Yeah, so the distance or displacement is 0.8. Initial velocity is 0, have half here. Acceleration is 0.4, and we have t squared. Yeah, that's what we're trying to find, t. So then let's bring everything to the other side. We have t squared equals to 4, and then we have t is equals to plus minus 2, and since we're dealing with time, definitely we're going to take the positive 2 seconds. Okay, and that's your answer for part 2. Now let's move on to part 3. So when Q hits the floor, the string becomes slack. Find the time from the instant that P is released for the string to become taut again. So when this happens is that when Q reaches the floor, P reaches at a certain point where it's no longer being affected by the particle Q. So it's moving on its own, going up, but then suddenly go down to become at rest again. So what we're going to do is we're going to find the velocity. The final velocity using the initial velocity 0, final velocity when q reaches at the bottom. We know the acceleration is going to be the 0.4 that we're going to use, okay? We also know the distance that p traveled, which is 0.8, okay? They traveled the same distance. So which means we're going to use the formula of v square is equals to u square plus 2as. Now you can also use the v equals to u plus at because you recently found the time, right? So it's up to you. Now we want to find the velocity. Our initial is 2as. And our acceleration is 0.4. And then distance is 0.8. And then v square is equals to 0.64. And then v is equals to 0.8 meter per second. Sorry. Now we're not done here, right? So this v is going to be our initial velocity for the next phase. So now what we're going to do is we need to find the acceleration of p when it is not being affected. When it's not being affected by anything. So I'm going to use F is equals to ma, right? So in this case, when tension is no longer being applied, I'm going to have only the weight is being applied to it. So we're going to have 9/5 is equals to 0.3 acceleration. Okay, now we want to find the deceleration actually. And 9/5 divided by 0.3 will get you -6 meter per square second. Okay, so I'm going to take negative because of deceleration. Now let's move on. Now we can proceed with the calculation of finding the time. So we can use v is equals to u plus at. Final velocity is 0 because that's the maximum height. Initial is what we found, 0.8. Acceleration is -6. Then t. T is equals to 2/15 seconds, right? But this is only when p is going up and when it reaches to the maximum point. But question says for the string to become taut again. So taut meaning that p has to go down again. So the time taken to go up will be the same as the time taken to go down. So finalize your answer. Just multiply it by 2. You'll get 4/15. Okay. So 4/15 in 3 sig fig, that's 0.267 seconds. No, sorry. So it looks like when I read the question back, it's asking for which p is released, right? So it's talking about from the start, right? So this isn't your final answer. Instead, I'm just going to add 2 here, which would be 2.267 seconds, okay? Because of the time traveled from p up to the point where q reaches the bottom. Okay, so therefore it's 2 plus 0.267, which is equals to 2.267 seconds.